Matrix. It's really nice to have you here with us on this Tuesday afternoon. We're kind of halfway through our course on Euclidean geometry. Our previous two courses, we were talking about grade 11 circle geometry and how important that is to us in Matric. I don't know if I mentioned this last time, but I'm going to say it again anyway. When you write your trials papers later this year and your final papers, the section on Euclidean geometry is worth about 50 marks, and you'll find that 25 marks are grade 11 work and the other 25 are Matric work. So the grade 11 stuff is very, very important. Yeah, we need to be able to do our grade 11 circle geometry, especially if we want to I don't know, you know, we can sort of get away with the grade 11 work and sort of get sort of 40% of our paper. But if we want to do more than that, then we need to be able to access the Matric work as well. Okay, so the last time that we were together, I gave you a little bit of homework. So I just want to go back down to my slides and just go to where it was. So I gave you this question over here, if you remember. And I had asked you to do 2.1. I asked you to do question A, so proving that ABCD was a cyclic quad. Okay, so the solution is there in orange. Please take a screenshot of that so that you can go and mark what you have done. This was not meant to be particularly difficult. I hope it wasn't. But there is that question. And then the other thing that I gave you, hopefully everybody's got that. Did I give you another question? No, I didn't. That was it. Okay, so yeah, that was the question that I'd given you for homework. If you do want to try part B, C, and D at another stage, that's fine. I'm happy to share those answers with you as well, but it was just 2.1A for now. All right, so moving on to what we're going to talk about today. Before I actually get started, have any of you actually started the proportionality intercept theorem at school? Has anybody done grade 11, grade 12 Euclidean geometry at school yet? No, okay. Anybody else? Not yet, not yet. Okay.
Majority of us hasn't done it yet.
All right, so Ritabile is saying yes. You're the only person so far. Jabulani says no. Albertu says no. Fahim, yes. Mikhail, not yet. Timbeka, not yet. Angelique, yes. Okay, so there are a few of you that are saying yes, and then there are a few of you that are saying no. Okay, so in order to be able to accommodate everybody, I'm going to go pretty slowly because I think it's very important that we understand the basics of the proportionality intercept theorem, because if we don't, then trying to do the work becomes an absolute nightmare. So we need the tools for the job, so to speak. And I say that a lot in class to the children that I teach. You know, a lot of being able to do math successfully is having the correct tool for the job. So in other words, if somebody asked you to go and dig a big hole in the garden because you needed to plant a tree and you went outside with a pencil, that's not going to help you. You need a spade. So the basics are the tools that we need in order to be able to do the job. So I'm going to introduce the proportionality intercept theorem to you, and then I'm going to spend a little bit of time talking about what a proportion is and the various types of manipulations that we're able to make with proportions. Okay, so in Matric, the first theorem that we learn about is the proportionality intercept theorem. And what this theorem tells us is that if we have a triangle, okay, so like the one on screen triangle ABC, and we have a line that is drawn parallel to the third side of the triangle. So the line that is drawn parallel to the third side of the triangle in this case is going to be this green line that I'm highlighting over here. Okay, so that line PQ is drawn parallel to the third side of the triangle, the third side of the triangle being the one that I am now highlighting in purple. Right, and what it does is it cuts the other two sides into the same proportions. So the sides that it cuts into the same proportions are this side over here, side AB, and it cuts side AC into the same proportions, right? What that means for us is that they are in the same ratio. They are not necessarily the same length. All right, so for example, if I said to you that the ratio of AB is to PB is 3:2, then what I could say on the other side over here is that if AQ was 6, from here I've times by 2, so this would be 4 times, this would be 4, whereas that one would be 2. So they're in the same proportions, but they're not necessarily equal in length. Okay, now I see a couple of people have got hands ups. Asanda. What's wrong, Asanda? Maybe it was a mistake. I don't know. Okay, Asanda, if you still got a question, you're welcome to let me know or put something into the chat if you want. I'm gonna go on. All right, and then just remember to stay on mute, please, because if we're not on mute, then it disturbs other people. Thank you very much. Okay, so in its very basic form, this is how we would write it. We would say that side AP, okay, which is this little side over here, over side PB is the same as side AQ over side QC. All right, so if we just think about what that means in numbers, what we're saying is that 3/2 is the same as 6/4. Okay, so in other words, if I simplify my fraction on this side, so if I divide that side by 2 and I divide that side by 2, I'm going to get 3/2. So they're in the same proportions, but they're not necessarily the same length. All right, and then when I make a statement like this, I have to substantiate my answer with a reason. So we are allowed to abbreviate it, and I can abbreviate it to proportionality, intercept theorem. I can abbreviate it like that, and then I have to name the parallel lines. Okay, so like corresponding alternate and co-interior angles, the proportionality intercept theorem does not exist unless we have parallel lines. So we have to name the parallel lines as part of our reason. If we don't, in finals at the end of this year, they will deduct a mark away from you. So if you write proportionality intercept theorem and you neglect to write this bit, they're not going to give you the mark for the reason. Okay, some schools, they might have taught you a different reason. They might have said line parallel to one side of triangle. That is the other not abbreviation, but other accepted, yeah, I suppose it is an abbreviation. I don't generally tend to teach that one, but if that's what your teachers taught you at school, then you're more than welcome to go with that as well. Okay, so now I see there's another, Anthony, I see you've got your hand up. I don't know if that's a mistake or if you want to ask a question, Anthony.
Ma'am, why are you dividing by 2, ma'am?
What I'm saying, so what I'm saying, Anthony, is that 3/2 is the same as 6/4. That's what I'm saying. So these are numbers that would be given to us, for example. Okay, so if the length of AP is to PB is 3:2, yes, then on the other side, if it's in the same proportion, then it could be 6/4. There's other numbers I could use as well if I wanted, Anthony. Those are not the only numbers. It would depend on the length of the side. So if I say it's 3/2, then on this side over here, I could have 9, I times by 3, I could have 9/6. Okay, so it just depends on what ratios they have given you. Okay, Lusanda, do you have a question?
Ma'am?
Yes, hello.
Ma'am, can ma'am please repeat? Ma'am, can ma'am please repeat the statement you said about the line that you highlighted in green?
Can I repeat the statement about the line, which?
You highlighted in green in the triangle.
Okay, so this line over here that I highlighted in green is the line drawn parallel to one side of a triangle. Okay, so a line drawn parallel to one side of a triangle, that is the green line over there. Okay, that's the line that's drawn parallel. To the side of the triangle is the purple line. And the other two sides that it cuts proportionally are the lines that I've highlighted in pink. So in other words, this line over here and that line over there. Those are the two sides that are cut into the same proportions by this line. So in other words, the length of AP over the length of PB is in the same proportion as AQ over QC. Right. So what I want to do now is just elaborate a little bit more about proportions, because in order to be able to work with a proportionality intercept theorem, we need to understand all of this. Oh, by the way, did you take a screenshot? So take a screenshot of that. So the heading, the explanation, and then the diagram. And then when I show you this other little bit here in orange and sort of yellow on the side, I want you to take a screenshot of that as well. Okay. All right, so I'm going to move over. And now I want you to take a screenshot of the bit that's on the screen at the moment. Okay, sorry, I'm just moving over here. Okay, so this bit that's here in the middle. Okay, so let's get started, all right? First of all, I want you to understand that a proportion is a relationship between four things, okay? So this over here is called a proportion. So if I say to you 1/2 is the same as 5/10, that is a proportion. Okay, so that relationship is called a proportion. It does not mean that the numerators are equal and the denominators are equal, because they're not. Okay, 1 does not equal 5, and in the same way, 2 does not equal 10. Okay, but 1/2 is the same as 5/10. So they have the same basic value if we go and simplify, right? So now I want you to consider, we're going to assign A, number 1. So I'm talking about the A from here. That's going to be 1. B is going to be 2. C is going to be 5, and the D is going to be the equivalent of 10, right? And I want to just go through what happens when we apply these manipulations. All right, so I'm just going to make this a little bit bigger. Okay, so the first thing over here, it says to us, we can invert both sides. So if I invert both sides, what I'm doing is I'm switching the numerator and the denominator around. So in other words, I'm saying that 2/1 is the same as 10/5. That's why you're allowed to write B over A is the same as D over C. So if you switch both of them around, then that's perfectly acceptable because it's still true. Okay. The second thing that I'm allowed to do, all right, is that the ratio of the numerators is equal to the ratio of the denominators. Okay, so in other words here, what I'm saying is this, is if I compare 1 and 5, so the ratio of the numerators, so 1/5, it is the same as 2/10. And you see, I'm comparing the numerators. Here I'm comparing the denominators. All right, so that would be the same as me saying A over C is the same as B over D. Okay, so these are the manipulations that I'm allowed to make. Right, so in other words, I can put things in different places, provided it still makes mathematical sense for me to do that. And this is something that I'm going to be expected to do in Euclidean geometry. The third thing that is important for me, okay, and I'm only going to go through the first 5, I'm not going to worry about 6 and 7 today, is this idea. I am allowed to cross multiply. So in other words, if I go back to my original fraction, I said 1/2 is the same as 5/10. I can cross multiply. So in other words, I can say 10 times 1 is 10, and it is equal to 2 times 5, which is also 10. Right, so I am allowed to write 1 times 10 is the same as 2 times 5, which also gives me 10. So cross multiplying is also allowed. So in the case of A over B, what was it originally? A over B equals C over D, A over B equals C over D. You are allowed to cross multiply as well. So in other words, A times D is the same as B times C. All right, then the other thing that I want to show you, and this is something that you actually know already from, gosh, I mean, the first time you would have seen this could have been as far back as grade 8. It is possible to make one of these the subject of the formula. So in other words, if I take A over B equals C over D, let's say I am asked to solve for A. All right, I can cross multiply B and C together and make A the subject of the formula. So in other words, A is going to be equal to B times C over D. I'm allowed to do that. The reason why it works is because if I have got 1 over 2 is the same as 5 over 10, and I want to make 1 the subject of the formula, I can say that 1 is equal to 2 times 5, which is 10, over 10, and we know that anything divided by itself is 1. All right, so these are the various manipulations I am allowed to make. Yes, absolutely. Please take screenshots. Okay, and then the last one was if we wanted to work with the denominator. Okay, so if I've got A over B is equal to C over D, if I want to make B the subject of the formula, the easiest thing for me to do is this. Okay, so if you need to make something that's at the bottom, the subject of the formula, invert, because you know you're allowed to do that. So B over A equals D over C, and then cross multiply. So that means that B would be equal to A times D over C. All right, so now in terms of our numbers, all right, the reason it works is this, because 1 over 2 was 5 over 10, right? That's where we started. Then we inverted, and then we cross multiplied. So in other words, 2 is equal to 1 times 10 divided by 5. 10 divided by 5 is 2. That's why we are allowed to make these manipulations with these letters. Okay. Nolwazi, we will go over them, but I'm not going to do it in today's lesson. I'm going to do it when we do the stepping up. Okay, but I will come back to this and I will explain it to you. I just didn't want to throw too much at you all at one go. Okay, especially if there are people that are doing this that haven't done the proportionality intercept theorem at school. Okay, so are there any questions on what I've just explained before I move on?
Visanga, I think, has their hand up. Visanga, do you want to ask any
That's
questions?
fine.
Visanga, you see, you must unmute yourself. You are muted, so we cannot hear you. If you have any question, you can ask. But so far, Asanda, I think we're going to give you a chance. Ask, ma'am. Let's go. Let's do this.
Okay, ma'am, I wanted to, can you please re-answer number 5? I didn't hear number 5.
That's fine. I see there, Kanyisile was also asking about number 5, so I'm happy to go through that again. All right, not a problem at all. Okay, so let's just go through number 5 again. This is what I was trying to say to you. So in other words, if you want to make something that is in the denominator, the subject of the formula, okay? So in other words, we have got A over B is equal to C over D. Now what we want to do is we want to make this number over here, this letter B, the subject of the formula. The easiest way for you guys to do this, all right, is to invert it first of all. Now remember, inverting was the very first thing that we did. We said that if we switched both fractions around, that it was perfectly acceptable for us to do that. So what I want you to do is I want you to invert it so that B is in the numerator, A is in the denominator, and then we've got to do the same thing on the right-hand side. We've got to put D in the numerator and C in the denominator. Now we want B on its own. So we're going to cross multiply A with D in order for B to be left on its own. So B is going to be equal to A times D divided by C. Now I want to show you how this works with numbers. So if I've got 1 over 2 is 5 over 10. Now I'm going to invert them. 2 over 1 is the same as 10 over 5. I want 2 on its own. So I'm going to cross multiply 1 and 10 together. So 1 times 10 divided by 5. So 10 divided by 5 is 2. This is why it works. Okay, so essentially what I've done is I've showed you how to invert, how to write the ratio of the numerators equal to the ratio of the denominators. I've shown you how to cross multiply. So we're converting fractions to a product. And then I've shown you how to make something that was in the numerator, the subject of the formula, and how to make something that was in the denominator, the subject of the formula, because you are going to be doing these manipulations as we go through. Okay, so proportionality intercept theorem, Tembani, is used, it's like, it's another Euclidean geometry theorem that we learn about in order to be able to solve the lengths of sides in triangles where there is a side parallel to the third side. Okay, so that's the idea. Okay, okay. All right, so what we do, Dikeledi, is that in order to be able to, it's a pleasure, Tembani, so in order to be able to sort of accommodate most people in South Africa, because all schools, all government schools have the ability to do things differently. So my school too, we also don't do Euclidean geometry with the matrics in the first term. We also do it in the third term. But according to the ATP set down by the government, okay, we are following that. So there are a lot of schools that would have done sequences and series, and then the next thing that they would do would be inverses and functions, and then they move on to this. So we are just working according to the government ATP in the hope that most of you, most students, would be following the ATP as well. Okay, so if you don't do this now, you are eventually going to do it at some stage at school. Okay. All right, so let's just go back to this and go and practice writing some proportions. All right, so what I want to do is I want to just get rid of that so that the triangle is not compromised. And what we're going to do is we're going to use this triangle to write some other statements about the sides that we're working with. Okay, so the first one that we've got here is, so I'm looking at this now where I'm highlighting this in purple. All right, so AP over AB. Can you see what they've done here? AP is this side over here. Okay, AB is the whole side. Okay, now we need to do the same thing on the other side. All right, so AP over AB is going to be the same as what? What do you think it would be? Unam, what do you think it would be?
You'll have to unmute on your side, Unam. Okay. Atanda, do you have an answer?
Okay, oh, there we go. There's a whole bunch of people putting stuff into the chat. Let's see what they're saying. AQ over. Lovely, guys. Very nice. Wonderful. Well done. Quite right. Absolutely. Good. You're getting the hang of this. Brilliant. That's excellent. I'm so pleased that you can see that. So it would be AQ over AC. All right. Well done. That's excellent. Very nice. All right, let's do the second one. So now, let me just get rid of the thing over here. Now we've got PB over AB. All right, so I'm highlighting this in green for you guys, PB over AB. Okay, so PB is this little bit over here, and AB, again, is the whole side. So what are we going to say on the other side here? What do you guys think? You're welcome to pop it into the chat. QC over AC. Excellent, excellent. QC over AC. Well done, everybody. Brilliant. Wow, look at those answers flooding in. Amazing. Well done. All right. I'm really, really, really pleased. That's brilliant work. Okay, so because these are the basics. If we understand this, we can do absolutely anything. Well done. Okay, nice. Now here's another one, although actually I think this one is actually very much the same as the one that we did before. So I tell you what, let's not worry about that one too much. Okay. And then they want us to write the proportions above as a product. So in other words, if I've got AP over PB equals AQ over QC, I can write it as a product. So this is where I'm cross multiplying. Okay, so I'm multiplying, sorry, that's supposed to be a Q there. I'm multiplying QC, that's supposed to be a Q, with AP, cross multiplying, and then on this side, I'm cross multiplying as well. So how would I apply that thinking to this one over here? If I wanted to cross multiply, how would I write that? So you can, again, you can pop it into the chat. How would we write that if we wanted to write that proportion as a product where we were cross multiplying? They are, aren't they? You don't have to invert the fraction in Pumulelo. You just need to cross multiply for this one. We're just writing it as a product. So let's have a look at what you guys. Very nice. Yes, let's have a look. Homolemo, Sharon, AP times, that's it, AP times AC equals AB times AQ. Good, Tundle, where to? Okay, so here, when we are cross multiplying, we're multiplying these two together. So that gives us AP times AC is equal to, cross multiply the other two, AB times AQ, like so. Okay, so I'm cross multiplying. Let's see if we can do that with the next one. Write that as a product. So the one that's got the rainbow ring around it, let's write that as a product. Very nice. Yes, Luam. Good. Lovely, lovely, lovely. Very good. Oh, you guys are smashing it. Okay. Excellent, 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 excellent. Brilliant. Yes, Tina.
They are really on fire
There
today.
we go.
I
They
like
really
this.
are on fire today. I'm so super impressed, guys. That's great. So we can write this as PB times AC equals AB times QC. Okay, and that's exactly what you guys were popping into the chat. All right, brilliant. So now we've had a little bit of practice working with these manipulations. So what I'm going to do is I'm going to jump over that. I'm going to go straight to the first example because I want to give you guys an opportunity to try a question like this. Okay, so here is our basic entry-level sort of question. They've told us that AB is equal to 12. Okay, so that's this bit over here. It's 12 centimeters. And they've told us that FB, so this little bit over here, is equal to 3 centimeters. They've told us that GC, so that's this bit over here, is equal to 14 centimeters. And the question is calculate the length of AG. So in other words, that's this bit over here. Got to calculate the length of AG. All right. So now, based off different types of proportions that I can make, I can either compare AF with FB and thus AG with GC, or I can compare AF to AB and AG to AC, or I can compare the little bits. So I can compare FB to the whole side AB and GC that little bit to the whole side as well. Okay, but the point is whatever proportions I make, it's got to be the same thing on both sides. All right, so if they give me the length of a whole line and they give me this little bit over here, I can use subtraction. So in other words, I can say that AF is going to be 12 centimeters minus 3 centimeters, which means that AF is going to be 9 centimeters long. Okay. On this side over here, I only know that GC is 14. The one that they want me to calculate is AG, right? So what I'm going to do is this. I am going to take AG and I'm going to pop it into the numerator simply because that's just easier for me and I don't have to make any further manipulations. And I know that if I put AG over GC on the one side, I can put that over what on the other side. So AG over GC on the side on the right is going to be equal to which side over which side on the left. So I just want to address this. You cannot use the theorem of Pythagoras because it is not a right angled triangle. Okay, not a right angled triangle. So AF over FB, very good, well done. Okay, AF over FB. All right, brilliant. Okay, what's the reason? What's the reason, Matrix? Remember, I'm writing a Euclidean geometry statement. I have to write a reason. So what's my reason going to be? Yes, AF over FB is correct. What is my reason? Can anyone pop that into the chat for us? Yeah, check your screenshots. That's good. Homolemo, that's right. You've got the correct answer, but let's just make sure that we don't lose any marks along the way. There we go. Nalwazi, that's very nice. Thank you. Proportionality, intercept, theorem, and I must not forget to name the parallel lines. So in this case, it's because FG is parallel to BC. Excellent. So now that I have this, now I can go and substitute in my sides. Okay, so remember AG is the one that I want to solve for. I know that GC is equal to 14, so I'm subbing that in there. AF I know is 9 because I calculated that. And FB I know is 3. Can you see we want to make AG the subject to the formula? Okay, so this is what I was trying to show you up here in number 4. Okay, so remember on the side here when I did example number 4 and I showed you how to make A the subject to the formula. This is what we're doing now where we are cross multiplying. Okay, so we're putting these skills into use here. All right, let's just go back down over to the side. Let's just see what you guys are saying in the chat. Okay, so a lot of you are giving answers. Very nice. So you would have ended up with 3AG equals 9 times 14, which leaves us with 126, and you're all perfectly correct. That means that AG would be equal to 42. Brilliant. Brilliant,
Well
brilliant,
done,
brilliant. Very
Yeah.
nice, guys. Excellent work. Very, very, very nice. Okay, I'm super, super impressed. Okay, so now try and take a screenshot of that so that you've got it with you. And now you guys are going to try one on your own. Okay, so I'm going to move this down and I'm going to let you try one. So I'm moving it down now. Okay, in fact, there are 2 here that you're able to try. Okay, it was just a little typo here. Let me just fix that. And if you're a fast finisher, then there's a second one for you to try. Okay, so here they meant to say calculate the value of X, not the value of Y. Okay, are there any questions? So that if you don't have any questions, please get cracking. And if you do have any questions, you're welcome to ask now. Go for it, Lysander.
Ma'am,
Hello.
ma'am, I wanted to know that if they give you a triangle, they can never give you a triangle with more than, let me see, let me count, more than more than six sides.
A triangle with no, so no, because a proportion only has 4.
Okay, ma'am.
There's only 4 sides. Okay, so it's the 2 sides that have been cut proportionally that we are talking about. Okay, so in other words, PQ and PR. Okay, so we can compare PS with SQ, or we can compare PS with PQ, or we can compare SQ with PQ. Okay, so there are 3 different types of proportions that you can make.
Okay, thank you, ma'am.
Oh, wow, you guys have already got an answer there. That's amazing. Okay, right,
So
remember
fast.
yeah, that is very fast. Remember, you've got to set it out in the correct way. All right, so if you don't write your reasons and you don't name the parallel lines, they're going to penalize you. Okay, and we don't want you losing any marks. Good, yes, well done. That is true. X is equal to 4. So I'm going to start putting up the solution to number 1. I'm just going to move myself out the way here, and then you guys can try the second question. All right, so in number 1, you would have had something that looks like this. And then we would have substituted. Okay, and now if we want to practice what I had said about inverting, we could do that. And then cross multiplying in order to solve for x. Okay, so if 5x equals 20, then x was equal to 4. Okay, so let's see what answers you guys are giving for the second one and see if somebody can explain it to me. There we go. All right, very nice. Okay, Amate, not a problem. I'll just move it down a little bit. There you go. So you can take a screenshot of that.
Is it possible to make the answer sort of the center there, or not really? The
Answer in
that
the
you
center?
worked out.
I can put it more in the middle if you want.
Yes, I think that will help some of them. The ones that are asking, how did we get 4? So you can see a step-by-step that teacher Lee actually showed to us. So that will be nice.
Like that?
Yes,
that
maybe
better?
like that. Guys, I hope you got your
Okay.
screenshot.
So here we go. It's step by step how we ended up with the answer of 4. Are there any questions? Here it is.
I see people are already on number Y. They're already trying to find Y.
Oh,
So
wow. Okay.
we are moving
Right.
on.
Okay, very nice. That's fine, Rasimpi. We're going to talk about that now. Okay, Teddy,
Is
you've
that
got a
a
hand up.
question?
Go for it, Teddy. Ask your question. I'm just going to move this down a little bit so people can see. Go for it, Teddy.
Can you hear me?
Yes, I can hear you. How are you?
I'm good, thank you, ma'am. And yourself?
That's good. I'm fine, thank you. How can I help?
Can ma'am triangle PQR, ne?
Which one, Teddy?
Triangle PQR.
So do you mean side PTR? Are you talking about
No, like I
question
wanna
number
know.
1?
Yeah, question number 1, ma'am. I wanna know when you like trying to find the one side
does it have you? Can you say TR over PS, like the other side of the triangle, or
Okay, just hang on, let me just write down what you're saying. So can you say TR? No, you can't do that. You can't do that. So you can't
compare
put
the one side with the other side.
Yes, absolutely. So what you can do is this, all right? If you want to compare, because remember you're allowed to compare numerators and denominators. So if you want to put TR over SQ, that's allowed. And then you've got to say that it's the same as PT over PS. That you're allowed to do. Okay, so numerator over numerator is the same as denominator over denominator. That's allowed. So here, if you went x over SQ, which is 2, is the same as 10 over 5. Can you see here you'd get the same answer by cross multiplying? You'd have 5x equals 20. So x would be equal to 4. But you can't put TR over PS. And you can't put PT over SQ.
Okay.
Okay,
Understood.
all right. I'm so glad you asked that question. That was a very, very good question to ask. Well done. Okay, so I see there's a lot going on in the chat. How did you get the variable y? Okay, so no problem, Nompumelelo. There are a few people who struggled with this. Okay, so let's see. Who was the first person to give us an answer for y? So it says Zoom user here, but I don't know who that is. Zoom user, who are you? Who's on as Zoom user? You must actually give us your name and then we can change it for you.
Definitely, we can change it and we can stop calling you Zoom user.
Yeah, I'm stop calling you Zoom user. Because I'd really prefer to hear from one of you guys instead of me explaining it. Okay, so how about Intwana? If I've pronounced that correctly. Can you explain to us how you got y is equal to 15? Is there anybody who's prepared to give us an explanation on how they got y is equal to 15? Anyone prepared to share their answer?
Maybe Teddy. Teddy's hand is up.
Sure, Teddy, go for it. Okay. And then Luam's also said so. All right. So Luam, if Teddy doesn't get it right, then I'm more than happy. And Davis, I see, has raised a hand as well. Okay, go for it, Teddy.
Oh, ma'am, sorry. That was the hand, like, when I asked the first question, so I didn't.
Oh, was it? Oh, sorry.
I'm
Okay,
sorry.
Teddy, never mind. No problem. Okay, Luam, it's all yours. Go for it.
Okay, so what I did was that since you look for y, I put y over the full, like, the full over 35, since that's what's given to us. And after I equaled it to E over CE, since
so
that's
you
what
equaled it to DE over
CE, since it's the same as what we're doing with y, which is BA over CA.
Yes,
and then
lovely.
And how I got CE was I added 24 and 18 since we wanted the full side.
Yes, absolutely. So you ended up writing AB over AC is equal to DE over CE. Lovely. And then your reason, Luam?
It's prop int theory BD, which is parallel to AE.
Fantastic. Wonderful. And now we're going to substitute. So tell me what you wrote next.
So I wrote Y, which is over 35, which equal to 15 over 42.
Beautiful. Oh, wow. That is stunning. Well done. What a fantastic explanation. Okay. And then you?
So what I did was I was a little different, was that I took the 35 and after I times it by 18 over 42.
Okay. Okay,
and then I got
that's fine.
After I got 15 centimeters out of that.
100%. Okay, so over here you said 35 times 18, which you then divided by 42. That was absolutely fantastic. You know what? I think you should be the teacher from now onwards, because that was a
Okay.
brilliant explanation. Thank you so much. That was really great.
problem.
Brilliant work. Thank you. Okay,
Yeah,
so
cool.
hopefully the rest of you understood that, because I certainly couldn't have explained it any better than Luam did. Well done. Very, very nice. Okay, Anthony, I see.
Yes.
Yes, go
Anthony,
for it, Anthony.
Ma'am, did you plus the 24 and the 18?
He did. Yes, that's exactly what Luam did. So in other words, the length of this entire side over here would be 24 plus 18, and that's where we got the 42 from. Okay. Very nice work. Okay, brilliant. Let's go and have a look. And I'm not trying to do this to try and sort of, what's the word? Bombard you, but I just wanted to give you as much practice as possible. Okay, so here are two more questions, number 4 and number 5. In fact, you know what I'm going to do? I'm going to do this. So you guys can start on number 4, and then what I'm going to do is I'm actually going to get you guys to do number 6 rather. Okay, so number 3 and number 6, please. Very well.
I'm not sure if Anam's hand is there to ask a question, Anam.
Ma'am, I wanted to ask, how would you do it if you would do the cross multiplication in number 2?
Okay, so in other words, if you are cross multiplying, right, so I just want to recall what it was that Luam told us. So if you remember, everybody else continue working. If you understand, I'm just doing this explanation here on the side. So Luam had y over 35 equals 18 over 42. So what you were doing when you cross multiply is you're multiplying 35 and 18 and 42 and y. So you end up with 42y is equal to 18 times 35. So that means that 42y would be equal to 18 times 35 leaves us with 630. And then we are dividing both sides by 42 in order to get our y, which was equal to 15. Okay.
Okay, ma'am, I understand. Thank you.
Pleasure, pleasure, pleasure. Any other questions while we're busy working?
My people, you are on it today. You are on fire. Let's go.
Sure, these metrics are doing well. Hey, Yolanda. Very
Yes,
good.
really, really well.
It
Especially
is,
this
isn't it?
section. I was like, wow, I'm
Yes.
so impressed.
Me too. Good job, everybody. All right, so if you managed to do number 3, you're welcome to continue on and try number 6. Sure, thank you for all these answers, guys. This is brilliant.
To remember to practice the right reasons always, because that's important, and it's through practice that it sticks in your head.
Okay, so some people are putting down answers for PT as well, which is really nice to see. Well done. That's it, Timbani. Quite right. Okay, and now you're going to get full marks. Yeah, as Yolanda says, very important that we provide reasons as well. Okay, and again, I really love your explanations. You guys do this so well. Is there anybody who's prepared to share how they got the answer to question 3 with us in the same way that Luam did so very, very well earlier? Anybody prepared to explain how they got Emma's 4?
Come on, guys, we can do this. We can clearly do this. Lindo,
Absolutely.
I'm gonna pick up on you. You're gonna tell us the answer. Oh, Tina is already on number 6, guys. Tina is doing the question 2, which is level 6. So Tina, do you
Okay.
wanna yeah.
I see Teddy's put his hand up again. Teddy, do you want to have a try?
Ma'am, so we'll go with DG over GE
Uh-huh.
equals to DH over HF. And then we cross multiply, we will get 3M equals to 2M plus 4.
Hold on, I'm just writing your reasoning there. Sorry. So you've got M over 2 equals M plus 2
M plus
over.
2 over 3.
Lovely, okay.
And then we cross multiply.
Fantastic. So when you cross multiplied, what did you end up with? So you would have ended up with 3M times. Oh, sorry, 3 times M equals 2 times M plus 2. I don't know if Teddy's disappeared.
No, I'm still here, ma'am.
Oh, you still here? Oh, sorry, Teddy, please continue. Sorry, I beg your pardon.
And then we're gonna get 2M plus 4 with the other side. Then we do algebra to solve for M.
Beautiful. Oh, Teddy, that is fantastic. Well done. Brilliant. Okay, fantastic.
Done.
You and Luam are going to have to take turns teaching from now onwards because you guys are brilliant. That's excellent. Thank you so much, Teddy, for sharing your answer. I so appreciate that. That's brilliant. Okay, and then anybody like to do number 6 first? Please. You guys are doing this. Is it Yande?
Yeah, Ayanda is
Ayanda.
there.
Okay, Ayanda, you're welcome to do number 6 if you'd like.
Yes. Can y'all hear me?
Yes, we can hear you. Go for it, Ayanda.
Okay. I did I said 35 minus 14.
What were you calculating when you did that?
PQ
PS.
PQ O minus SQ.
There we go. Lovely. Okay. All right. Fantastic. And then there you would have obviously ended up with 21. Lovely. Okay. Fantastic. Keep going.
So PQ over PS equals to PR over PT. The reason is the prop theorem. ST is proportional to QR.
Lovely. Okay. Fantastic. Keep going. This is wonderful.
Then I substituted 35 over 21 equals to 25 over PT.
Nice. And now what did you do?
Then I inversed it.
Okay.
So 21 over 35
is equals to PT over 25.
Beautiful. Okay, very nice. And then from here, you?
Cross multiply.
Fantastic.
PT equals to 21 times 25 over 35. And
That's it.
PT equals
Lovely. PT equals?
15.
Fantastic. So 21 times 25 over 35, and that means that PT equals 15. You guys are
Well done, Ayanda.
incredible.
Wow.
Absolutely brilliant. I'm so impressed. Big hand of applause to all of you this evening for your incredible work tonight. That is really quite something, especially for a lot of you who have not even done this at school yet. So I'm super impressed. Okay, so tonight is the night of the quiz. So we're gonna, is it a quiz night?
No, it is all day.
It's okay. And if you guys want to, there's some homework for you as well. This question is just slightly more difficult than what we've done, but still fine. So you're welcome to take a screenshot of that. And then you can go off and try the quiz. Okay, very well done to all of you tonight. Thank you for making this such a pleasurable experience. I'm always just so humbled at how incredible it is to work with young people such as yourselves. So thank you so much. And I hope you have a wonderful rest of the week.